Good morning to all of you. My name is Manisha Verma. I'm from the Computer Science Department, FET, Rama University. Today I'm just telling to you about the virtual memory. Basically, the virtual memory concept is an operating system. So, that is the most important topic in the operating system. That is a virtual memory. So, starting of the virtual memory, I'm just telling to you what is it and why we are using the virtual memory whenever we are using the memory concept is already. So, suppose we know about it, about the main memory, we are already knows about it. Main memory size is 4 GB, 8 GB, 16 GB, max to max 16 GB. It is okay, but nowadays the process size is going to be increased. Suppose if process size is larger than the main memory, like a 250 size of the process size, and it want to be execute, but the memory size is 16 GB. So how can we execute and how we will provide the data to CPU? Then that time the virtual memory concept came, and it will say whatever process size it has, it doesn't matter, it will execute. So in simply we are saying virtual memory, basically it creates the illusion कि whatever process size it has, it doesn't matter, it will execute using this smaller memory, whatever it take it. After that we are just going out about the virtual memory process. So understanding of the virtual memory, we have to just know about the some basic concept of the virtual memory. Like first is that LAS, the full form is that logical base address. In the logical base address, as you can see, multiple processes are residing here, and those processes are divided into number of pages, like P1 as you can see, P2 as you can see, and same as P3, and the lot of processes are residing here. Same thing, suppose CPU demand process P2 of page number 4. Then after that we will provide that particular page number to CPU. But rather than, keep in mind, we never put in the full process of P2 into main memory. We are just putting only particular page number into main memory, and after that it will provide to the CPU. That is the basic concept, is that we are not filling the full process, we are just putting only the page number. After that LAS, logical base address, is basically linked to the LOR, that is called the locality of reference. So what is it? Basically, locality of reference, I am just giving the live example. Suppose a teacher take a student, take attendance to the student, and then after that what happened? The teacher called the roll number 7. Roll number 7, after that the roll number 8 of 8, roll number 9, roll number 10 is already be ready ki my turn is coming. Same here, locality of reference means if CPU call the page process P1 of page P2, then near about the pages P3, P4 and P5 is already ready ki now the next term is mine. So when we are putting the page P2 of process P1 in the main memory, and the near about pages P3, P4 and P5 is automatically come and put into the main memory. That is the basic concept of the locality of reference. So if I will go in summarize, so in locality of reference, basically near about those pages as the CPU demand, we are just putting into the main memory. The last concept is that the main memory. So main memory basically is we know about it, it is a temporary memory, and as main memory, basically it is a multiple number of processes are residing here. If the user call the process P1 and process P2 and process P3 and process P5, it will say every process are here. So user, the CPU think about कि every process is here, so it means it has a lot of process residing here? No, actually all processes are not residing here. There are only the page numbers of that particular process. So as we know about it, main memory is a temporary memory. When the second point, when main memory size is going to be full, then what happened, how to be insert the new process and new pages into the main memory. Then for that we are using the concept is writing here swap in and swap out. Whatever pages has used, the first point, and whatever process has no longer needed, we are just swap out that pages and we are just insert the new pages, that is called the swap in. For swap out and swap in process, we are using the different algorithms, like it is called as a page replacement algorithm. Page replacement algorithm, we know about it like basically it is a paging concept. First one is a FIFO, first in first out, LRU, least recently used, and third one is optimal page replacement. I'm just give you summarized point of view in both of three. Basically FIFO means first in first out, means we are just given the number of frames and number of pages are here. Number of frames means whatever sitting, how many frames, and we have a lot of number of pages, how we can insert that pages. Suppose if I want to insert the particular page that is already here, that is called the page hit. And same thing, LRU is a least recently used. Same, it is a back point of the FIFO. Same thing, when page is going to be hit, it is we are assuming in the LRU it is called the starting page of that particular point. And the third one is the optimal. In the optimal means basically it is a low, in which basically we are going to find out the lowest page fault. It means in which we are, when we are inserting the number of pages, so we are just looking whatever page has used and no longer needed in the past and the future. So we are just removing that particular page using this technique and insert the new page, that is the page replacement algorithm. Now the last point is that I am just telling to you how virtual memory works. Basically we have to understand when virtual memory works, it means we have a two concept is there. First concept is that when CPU demand, suppose CPU demand process P1 of page P1 to for executing. When CPU demand it, firstly it will generate the logical address, after that it will search the data into the page table. Okay, in the page table it will get it. So that is not a problem. In the page table we are getting the frame number 1 and it means we are getting the page 1 of process P1. So it's not a problem. That is just simple terminology is there. Second point, if CPU wants, same concept we are taking it, if CPU demand page P2 of process P1, so firstly it will again search the page table. Okay, it is not here. If it is not here, it means if that particular page is not in the page table, then it it is also called the page fault, or it generate the trap equal to page fault. Page fault means whatever pages is not here. After that there it is happen the context switch, then context switch from user to operating system. When operating system take the command, and after that operating system will search that particular data into the logical base address. Okay, after that operating system search it from here, it will get it from, okay, that whatever CPU demand the page number, it is placed here, then it will take it from here and put into main memory and update the page table and provide to the CPU. That's all the working of the virtual memory. Thank you so much.